All right, you guys, I just want to give you a quick review on 4.3 before we hop over to 4.4. We were going to draw and analyze rotated figures, and I just wanted to walk through the basics with you one more time. So we learned in the class before that there are some formulas we can use when we're rotating about the origin. And then when we don't have origin rotation, we translate the problem, rotate it, and then translate back. So let's do that problem together here. When in this scenario, we were rotating about -3, 5, so that's right here. Triangle ABC has the following vertices, and we are going to rotate it 180 degrees about -5, -3. Step number 1, move each point, move it to the origin. To do that, we're going to add 5 to all the x's and subtract 3 from all the y's. So for those of you guys who are like, oh, I don't like to write things down, I promise you, write them down. It'll make a whole lot of it'll make more sense if you have it written down than if you don't. This is a 3-step process. So step number 1 is add 5 to all the x's. -8 plus 5 is -3. -6 plus 5 is -1. -3 plus 5 is 2. And then we subtract 3, because what this is doing is it's moving us back to the origin. So each one of these is -3. 5 minus 3 is 2. 9 minus 3 is 6. 6 minus 3 is 3. So now we take each of these new points and we're going to do the 180-degree rotation to them. So we're going to take them and we're going to change the value of the x. We're going to make the opposite value of the x and the opposite value of the y. So instead of -3, we're going to have +3. Instead of +2, we'll have -3. Sorry. Instead of +2, we'll have -2. Changing the sign of each of our coordinates. Now, so we've rotated it. Now we need to move it back to our original point. So we're going to take each one of these and we're going to add 5 to each of the x's. Sorry, we're going to subtract 5 from each of the x's. And we're going to add 3 to each of the y's. So we're doing the opposite of what we did in the beginning. So -5 plus 3 is -2. 3 minus 2 is 1. -5 minus 1 is -4. And 3 plus -6 is -3. -5 minus 2 is -7. And 3 plus -3 is 0. So now we can see here's our original triangle was up here. This upper one here. And the new one is at -2, 1. -4, -3, and -7, 0. So it rotated it 180 degrees around. All right. So if I'm doing this for this problem here, we have our 2, 1, our 2, 4, and our 5, 1. We're going to do a 270-degree rotation about 7, 5. So the step number 1 is to subtract 7, subtract 5. We're going to move this to the origin. So we go -7, -5, -7, -5, -7, -5. To each of these points, P, Q, and R. All right, 2 minus 7 is -5. 1 minus 5 is -4. 2 minus 7 is -5. 4 minus 5 is -1. We'll just box these up for you. 5 minus 7 is -2. 1 minus 5 is negative 4. So now we're at the origin. We're going to do our rotation, and then we toggle back to our little formula sheet. It is 270. We take our x and y, we switch it, and then we make that new coordinate that sits in this position, we make it negative. So we go 270. We are going to switch the x and y and make the second one negative. Okay, so we're going to switch these. So we go negative 4, and instead of negative 5, it's going to be positive 5. So we switch them, and then we change that second one. So these switched, and then we change this from a negative to a positive. So these two are going to switch, and we're going to change that negative 2 to a positive 2. And then that, so once we apply the rotation, now we're going to move it back to our rotation spot. So we have, before we minus 7 and minus 5, we're going to add 7 and add 5. So our first coordinate was P. It started at over 2 up 1. Its new point is going to be at 3, 10. And then when we add 7 and add 5 to this, we get 6, 10. So our new Q prime, is going to be at 6, 10. Our old Q was at 2, 4. Sorry. And then R, we're also going to add 7, add 5. So our old R was at 5, 1. And then our new one is going to be at 3, 7. New R, R prime. All right, let's make it a legit triangle. And so what we did was we started at 7, 5. We moved all the coordinates back 7 and down 5 so that we'd be at the origin. Then we did the rotation operation to it, and then we moved it back over 7 up 5 to get our rotated point. All right, that was 4.3 review. Thanks for hanging in with me. They have this cute little question here. It says, we have this flag that Kendrick is designing for us. Describe how the 2 yellow stars would be affected if they were rotated 90 degrees counterclockwise. So we have our 2 yellow stars, and they're going to go counterclockwise 90 degrees. So if that looks, it's going to arch around. This star is going to end up right about here. And then this star is going to arch around, and he will end up right about there. So this is going to look like, if the stars were rotated, they would curve around the top left sides of the white star. Together, the pre-image, so the old stars, and the image, the new stars, would create a semicircle of yellow stars above the white star. Okay. This was our assignment for page 259. If you haven't done these, take a moment, pause this video, and go back and do that assignment. We are going to move on to 4.4, composition of transformations. We are going to use multiple transformations. We're going to draw and analyze the figures created using those multiple transformations. Alrighty, so let's do this first example together. We have the y-axis, reflection in the y-axis followed by a translation along a -3, -2, -3. So the first thing we're going to do is the y-axis reflection. Here is the y-axis. This is the line we're reflecting across. So we're going to take this. I like to think of it as whatever distance we are from our line of reflection, we're going to replicate that distance. So we look at this point here, and this point here, and we're going to recreate those distances. So here's our line of reflection. So we are 2 away from our line of reflection. 1, 2. Here's our new point. We go 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 6 away here, and then 2 away here. Then we grab our line. Should we make it match? Why not? Purple for everybody. So here's our reflection along the x-axis, sorry, along the y-axis, check, followed by a translation, -2, 3. So we're going to take each of our points, we're going to go left 2 units because it's negative, and we're going to go up 3. So this one goes left 2, 1, 2, up 3. This one goes left 2, 1, 2, 3. And this one goes left 2, up 1, 2, 3. And let's get our line. Voila. We have our new coordinates. Let's go ahead and circle it. Woo! Okay. Let's take a peek at this one. I'm just giggling because I don't know what happened to P here, but he did not end up on any corner, but that's okay. We don't need him. Translation of 1, 1. So we're going to move everybody over 1, up 1, and goes over 1, up 1. B goes over 1, up 1. So this isn't our resting place. This is kind of we're in transition. Then we're going to reflect across the line y equals x. Let's put in our reflection line. Remember the line y equals x, it goes through the origin and then its slope is up 1 over 1. So this one, we take all of our coordinates. So we take all of our coordinates and we are going to switch the x and the y. So our P is at, let's look him up. He is at like -3.5, comma 7.5. So the new one is going to be at 7.5, comma -3.5. And this is for P. I put the primes in, but I don't think that'll help you. Okay, so our n that we went up 1 over 1, he is at -2, comma 2. So his new one is going to be those switch 2, comma -2. And that will give us our new n. And then B was at 2, comma 2. And the rule is when you're on the line of reflection, you don't change at all. So our B prime is still going to be at 2, comma 2. Okay. So our n prime is at 2, -2. So let's put our dot there. N prime. And then our p prime is at 7.5, comma, -3.5. Ooh. And that, let's get our line going here, reflects us across the y-axis. Y equals x. All right, that was fun. Let's go ahead, we'll bump here. So composites of transformation, when a transformation is applied to a figure and then another transformation is applied to its image, the result is called a composition of transformation. It's like a compound word, one application and then another. A glide reflection is one type of composition for transformations. A glide reflection is the composition of a translation followed by a reflection in a line parallel to the translation vector. So glide is reflection and then translation. Okay, let's look at a glide reflection here. Triangle PQR has vertices 1, 1, 2, 5, and 4, 2. Determine the coordinates of the vertices of the image after a translation along -4, 0 and reflection in the x-axis. So the first thing that we're going to do is we are going to take our x coordinates and -4 and our y coordinates and do nothing. So we have 1 minus 4 is -3. And 1 minus 0 is 1. Next one, 2 minus 4 is -2. And 5 minus 0 is 5. 4 minus 4 is 0. And 2 minus 0 is 2. So we go ahead and we're going to graph that just to see where it goes. So we're going to go 1, 2, 3, 4. It's right there. This one goes 1, 2, 3, 4, and 1, 2, 3, 4. So now we have to reflect it across the x-axis. Our x-axis is right here. So we're going to take each of these coordinates and we're going to repeat their distance away from the reflection line. So this one is 1, 2, 3, 4, 5. So it's going to go 1, 2, 3, 4, 5. So we are going to, our new P double prime, the little prime just tells you how many times it's had a change. So we're here, and we're here. All right, let's connect to the dots. La, 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 la. And there we go. So what is our image going to be? When we reflect across the x-axis, our x stays the same, and our y is the opposite. So if we were at -3 before, we're going to be at -3 again. Then the 1 is going to become negative. Okay. And then for this one, the -2 is going to stay the same. And the 5 is going to become negative. And then for our last one, the 0 remains the same. And the 2 is going to become negative. And then let's just take a peek that to make sure that matches. -3, -1, -2, -5, and 0, -2. All right. Let's go ahead and do this check. We have a triangle. JKL has vertices 6, -1, 10, -2, and 5, -3. Determine the coordinates of the vertices of the image after the translation along 0, 4, and a reflection in the y-axis. So what we're going to do is the x is going to stay the same, and the y is going to get 4 added to it. So our j prime is going to be 6, 3, k prime is going to be 10, 2, L prime is going to be 5, 1. Then when we reflect along the y-axis, so just the y-axis is here. So if I was a point here, I would then be a point over here. So our y stays the same. And our x changes signs. So our y is going to stay the same. So let's go ahead and populate all of the y's. And then our x is going to change signs. All right. So isometry. Isometry. I pause so that we can make sure we're saying it right.
Isometry.
Isometry. That's what I was saying, right? Pretty sure I was saying isometry. Okay, so we're going to do some isometries. An isometry has a rotation and a translation. So we just did, the glide was a translation and a reflection, and an isometry is a rotation and a translation. Okay, so we have A, B, and C as our vertices. Graph ABC and its image after a rotation 180 degrees about the origin and a translation along -2, 4. So we're going to do the rotation first, and if we look, oh, I closed it up. Okay, so if we look back to 4.3, okay, so our 180-degree rotation, the x and y stay in the same order, they just are opposite. So let's hop back. So we're going to go opposites. So it's going to be 6, 2, 5, 5, and 2, 1. And that's just for fun's graph, though, so we can see what's going on. So we're rotating this 180 degrees about the origin. So 6, 2 is right here. That's our A prime. 5, 5 is right here. It's our B prime. And 2, 1 is our C prime. All right, let's triangle it out. All right, so now we are going to translate it -2, so 2 units left and 4 units up. So we're going to take our coordinates. Do not judge me. If you judge me, I will cry. So we're going to take our coordinates. I'm just going to snip mine. And we are going to move the x coordinate 2 units left, which means we're going to minus 2. So that makes it 4, 3, and 0. And then we're going to add 4 to the y's. So 2 plus 4 is 6, 5 plus 4 is 9, and 1 plus 4 is 5. And we're going to go ahead and graph those puppies over here. So over 4, up 6. Is our new A. So because it's had 2 transformations, we're going to call it A double prime. And then B double prime is 3, 9, over 3, up 9. And then C prime is 0, 5, over 0, up 5. C prime prime. And then so our new triangle is here. Okay, let's do this check together. The endpoints of CD are -7, 1. So 1, 2, 3, 4, 5, 6, 7. Up 1, C. And then D is -3, 2. Let's make it a line. Graph CD and its image after reflection in the x-axis and a rotation of 90 degrees. A reflection in the x-axis is, it starts here and then it ends here. So that means our x-coordinates stay the same and our y-coordinates end up being opposites. So our C prime and our D prime, the x-coordinate is going to stay the same and our y-coordinate is going to change signs. And our y-coordinate changes signs. So let's go ahead and graph these. -7, -1, new C, C prime, and then -3, -2. It's our new D prime. Now we're going to rotate it 90 degrees about the origin, and a 90-degree rotation is it switches the x and the y, and then the first one becomes negative. So we are going to switch x and y and change the sign of the first one. So this will be C double prime. So changing the x and the y, and then the sign in the first one changes. Switch the x and the y, and the sign of the first one changes. So our rotation is over 1, down 7, 3, 4, 5, 6, 7. So that's our new C double prime. And over 2, down 3. And that's our D prime. So it just took this and went, rotated it 90 degrees. All right. So we can also combine 2 reflections. You just do one at a time. Reflections in parallel lines, the composition of 2 reflections in parallel line can be described by a translation vector that is perpendicular to the 2 lines and twice the distance between the 2 lines. So if your lines are going this way, perpendicular would be this way. So if you start with P, you reflect it across K, and then you reflect it across L, it's going to orient your shape the same as it was before. So 2 reflections means, you know, now you were in a mirror and then we reflected again, now you're back to what you originally looked like. And then the distance from your start to your end is twice the distance from your two parallel lines. How fun is that? So a composition of reflections across two parallel lines is a translation. So let's watch if we so we reflect this heart. Distance is preserved. Across line L. And then we reflect it again across, and then you look and go, okay, how far, if we're reflecting it, it's going to end up 2 line lengths away. So it's as if we just took our heart and translated it 2 distances, 2 line segment distances away from itself. Anyway, let's see some examples here. Reflection in the line y equals 5 followed by a reflection in the line x equals 2. So we're going to take this little shape. It is okay that it is not a, it's an arrow. It's totally fine. So we're going to reflect it across the line x equals 5, and that's this line here. So we're going to take these distances and preserve them up a little bit further. This one is, so it's about 1, 2, 3 boxes away. It's a smidge outside. And then this one is 1, 2, 1, 2.5. 1, 2.5. This is about 1.5. And then 2. Okay, get our line going here. A little bit further up. Okay, and then we reflect it across the line y equals 2. So it's 1. We just repeat these distances. It's 1 away from y equals 2. So the very point is going to be 1 away. This one is it going to be right here? This one is kind of 1, 2, a little outside of the 1, 2, right here. This one is like right there, and this one is like 1.5 away. All right. And we just draw the reflection. Oh, I lost my line. Okay, so you just do what it tells you to do. Don't make it any more complicated than that. The composition of 2 reflections in an intersecting line can be described by a rotation. So 2 reflections in intersecting lines, so here's your intersecting lines, can be described as by a rotation that is about a point where the lines intersect, so that's, for us, it's P, through an angle that is twice the measure of the acute or right angle formed by the lines. So the rotation is going to be twice the angle formed by the intersecting line. Oh, we're going to prove theorem 4.2 in exercise 30. That's going to be exciting. All right, let's take a gander at this. We've got this triangle. Are triangles ABC and DEF congruent? If so, what composition of transformation maps ABCD onto DEF? So we're going to see if these are congruent. So let's just look. A to B is 2. E to D is also 2. So that side length is the same. CB is 1, 2, 3, 4. EF is 1, 2, 3, 4. So the sides of the triangle are 2 and 4. And then we can check the slope of these. So we are from A to C, it's up 1, 2, 3, 4 over 2. 1, 2, 3, 4 over 2. So they are congruent. ABC can be mapped to DEF. So I just wrote the DEF coordinates. Let's go ahead and get some ABC. So as you're looking at it, if I rotated ABC 180 degrees, then I think it'll turn it upside down like EDF is. So ABC, A is at 1, 2, 3, 4. It's at 4, 1. B is at back to up, so -2, 1. And then C is at left 2, -2, 1, 2, 3, 4, 5, -2, 5. Well, we're getting our graphing practice in today, aren't we? So if we do 180-degree rotation, that takes our X and our Y and it changes the sign. So we start with, okay, that's not what I wanted. So we take our X and our Y, we make them negative. We're changing the sign. Okay, and then we have to see, okay, my Y's are all lined up, but my X's are different. So what do I have to do to -4 to get it to be 5? Because we want it to end up at EDF. How do I go from -4 to 5? How do I go from 2 to 7? How do I go from 2 to 5? Okay, you guys, I had a little clerical error. Let's fix it. The 4, I didn't have it negative here. It is -4. So that changes your A prime to 4, -1. And then, so to transform these coordinates into these coordinates, we have to, so this is, because ABC can be mapped onto DEF by a rotation of 180 and a translation I should have typed it, sorry. A translation along vector. So you look, how do I get from 4 to 7, 2 to 5, and 2 to 5? Oh, we have to add 3 to the x's and nothing to the y's. And then triangle ABC maps to triangle DEF. So we add 3, and you guys notice A goes with D, B goes with E, and then C goes with F. Because when we rotate this around, A lands in the D position, B lands in the E position, and C lands in F's position. And that's how we map it. All right, that is it for this lesson, you guys. Let's go ahead and march on to our assignment. Thank you for your patience and time. Have a great day.